Hello students, welcome to All Force e-learning channel. This is K. Nageshwara, your physics faculty. Today we are about to deal with the session number 43. Chapter name is Motion Under Gravity, topic name is Motion Under Gravity, first year Neet. Okay, so let us see what we can do today. So I'll start with this model, rocket exhausted with fuel. So a rocket was fired into sky. After reaching certain height, it's a fuel exhausted. It's fuel has been completed. So what happens then? Usually when rocket is fired, it goes to a certain height with accelerated motion. Continuously its velocity increases. If that is the case, whatever kinematic equations you will be using, in those kinematic equations, you have to keep A as it is. No need to replace with minus G because it has already overcome the force of gravity and it is going in the upward direction with accelerated motion. Okay, so continuously if its velocity is increasing, definitely after reaching certain height, though the velocity, fuel is exhausted, it will have some velocity. With that velocity, it will be able to further go to certain height, isn't it? So finally, let us try to find out what is the maximum height reached by the rocket under these circumstances. Okay, and one more important point, when rocket lifts off from the surface, its initial velocity will be taken as 0. Remember these points. So let us say from the ground a rocket is fired. After reaching a height equal to h1, what has happened? It is exhausted with the fuel. So by the time it has reached the height h1, it has already acquired some velocity. Now what happens further with that velocity? It will be able to move ahead. Let us say it has moved a height equal to h2. Okay, and after that what happens? It will fall back. Because whatever velocity it has acquired here, with that velocity it has gone. Now, during this journey h2, the rocket is completely under the control of gravity. So its velocity gradually decreases. By the time it has reached here, let us say its velocity has become 0. Okay, so it is going to fall back. Okay, so let us try to find out what the maximum height acquired by the rocket. Obviously from the picture it is what h1 plus h2. So it means our task is we have to find out what h1 plus h2 is. So okay, let me describe. Let rocket moves up with a resultant acceleration a, and in time t, let it is exhausted with the fuel. So in a time t, what has happened? Fuel is exhausted. In a time t, how much is the height acquired by the body? h1. So let us first try to find out what that h1 is. For finding h1, I will make use of this equation. S is equal to ut plus half at squared. And here s is h1. Just now I told you when rocket lifts off from the surface, its u will be 0, initial velocity will be 0. So this term vanishes. And no need to replace a with g. I'm telling you, the rocket is having its own net acceleration. So no need to replace a with g. Okay. So if I replace s with h1, a kept as it is, u is replaced with 0. So finally what we will be able to get? h1 as half at1 square. Let us take it as equation number 1. Next, by the time it has reached a height equal to h1, just now I told you it will acquire some velocity. Let us make use of this equation v is equal to u plus at to calculate the velocity, to find out the velocity. So velocity will be equal to how much? At, because initial velocity is 0. Where here, when the rocket has been lifted off from the surface, its initial velocity is 0. It starts from rest, in fact. So by the time it has acquired a height equal to h1, how much is the velocity acquired? At. So for this journey h2, what is the initial velocity? At is initial velocity. And what is the final velocity? 0. Okay. Now let us find out h2. h2 can be written as u square by 2g. What is this u square? Initial velocity square. This u is different. This u is not velocity at the starting point. This u is corresponding to this h2 distance. Corresponding to this h2 distance, initial velocity is how much? At. Okay. So you have to replace u with at. When you replace u with at, what you will get? You will get a square t square by 2g. Now just add h1 plus h2, you will get the maximum height to which a rocket has gone from the surface. So which is equal to how much? Half at square plus a square t square by 2. So you can take out half at square common, then you will have 1 plus a by g into half at square. So this is the maximum height acquired by the rocket. Okay, so let us have a quick glance on what has been completed under the name of motion under gravity. We have dealt with freely falling case, isn't it? In case of freely falling case, or if a body is dropped, initial velocity will be taken as 0 and acceleration will be taken as plus g. And these are the equations, kinematic equations. U is replaced with 0. Okay, so v is equal to gt, s is equal to half gt square, v square is equal to 2gs, and the sn is equal to g of n minus 1 by 2. Okay, so if a body is vertically projected in the upward direction, a will be replaced with minus g, and in this case u equal to 0 is not possible. If you have to project a body in the upward direction, definitely you have to give some velocity to the body. Some non-zero value of velocity should be given. Okay, so now these are the equations corresponding to vertically upward projection. V is equal to u minus gt, s is equal to ut minus half gt square, a is replaced with minus g, v square is equal to u square minus 2gs, sn is equal to u minus g of n minus 1 by 2. Okay, so in case of freely falling, these two quantities are fundamental quantities. Like if a body is released from a height equal to h, okay, if you wanted to find out velocity acquired by the body by the time it reaches the surface, this is v is equal to under root 2gh. If a body is dropped from a height h, how much is the velocity acquired by it? Under root 2gh. Time of descent is equal to under root 2h by g. Similarly, in case of vertically upward projection of a body, these are few fundamentals like maximum height acquired by the body if it is projected with the velocity u square by 2g is the maximum height acquired. Time of ascent and time of descent both will be same provided air resistance is ignored, u by g. Therefore, time of flight will be sum of time of ascent and time of descent. So T is equal to 2u by g. So these are few fundamentals. Okay, and we have dealt with this model also. This is a tower of height h. Okay, what if a body is projected in the upward direction and simultaneously another body is dropped from the top of the tower? Okay, so there are several parameters that we can explore. We have already explored. This is one kind of model that we have dealt with. The second kind of model is this one. If a body is projected from the surface, okay, it reaches a point P in a time t1 and it crosses the same point during return journey in a time t2 measured from the ground. Okay, we have dealt with this one also. The other one is tower model. If a body is projected in the upward direction with the initial velocity u from a tower of height h, okay, time of flight, we have derived expression for time of flight. How much is that? U plus under root u square plus 2gh by g. This equation is very important, and corresponding to this tower model, we have dealt with the balloon, hot air balloon model also. We have solved one problem. Okay, so this is another one. Simultaneously, three bodies were projected from the top of the tower. Okay, simultaneously, or with some gap also you can project. Here one body is projected in the upward direction, it has reached the ground in a time t1. Another body is projected in the downward direction with an initial velocity u. It is not dropped, it is thrown downwards. Okay, the time of flight is t2, and the third one is from the same tower, from its terrace it's dropped. Okay, so the time of flight is t3. So we have seen how t1, t2, t3 are related. Okay, so now let us proceed with one problem. A body is thrown vertically upward from a point A 125 meter above the ground. It goes up to a maximum height of 250 meter above the ground and passes through A on its downward journey. The velocity of the body when it is at a height of 70 meter above the ground is. So he is asking us to take g as 10 meter per second square. Let us try to understand the situation. I will consider the tower here. Of course, in the question he did not mention anything about tower. It was said that at a height equal to 125 meters there is a point. Okay, so I am imagining a tower of height 125 meter and I am going to project the body from this point. I'll call this point as point A. Okay, so it's projected, body is projected. What happens? It goes to maximum height and it falls to the ground. What was said in the question? It goes up to a maximum height of 250 meters above the ground. This 250 meters height is not measured from the top of the tower. This is a very important point. Some of the students, they get deviated, with this information. Sometimes they take this 250 meters of measurement from the top of the tower. It's not measured from the top of the tower. It is from the ground, So like this. So it has gone to a maximum height equal to 250 meters and passes through A in its journey. So what is happening? It has gone to the maximum height and it has come back. And at a height equal to 70 meters, the velocity of the body when it is at a height of 70 meters above the ground, he is asking about velocity of the body at this point. Okay, let us try to understand the situation. If this point is at a height of 70 meters above the ground, by the time body has reached this point from this highest position, or from the maximum height position, by the time the body has reached this point, how much is the distance covered? It's equal to 180. 250 minus 70 will give us 180. It means from this point, it starts with a zero velocity. Gradually its velocity increases. By the time it has reached here, it acquires some velocity. And how much is the distance traveled, or how much is the height of fall? 180 meters. In case of freely falling body, if height of fall is known to us, can't we find velocity acquired by it? Yes, we can find out. Okay, so whatever description here I have given, the same thing is written here. So velocity acquired if height of fall is equal to h is how much? Under root 2gh. Velocity acquired by a freely falling body when it falls through a height equal to h is how much? Under root 2gh. Okay, and how much is that h? 180 meters. G is 10 meter per second square. Sorry, yeah. V is under root 3600, and finally what you will get 60 meter per second is the velocity acquired by the body. So how much is the velocity acquired by the body? 60 meter per second. And here I would like to tell you something. If you see the question, so many details are there, like 125, 250, 70, a lot of other details are given, but all those things are of not use. Did I substitute 250, 125, 70 anywhere? No, I did not. So first of all, if you look at the picture very carefully, if you draw a diagram, it is obvious that all that you need to do is you have to calculate velocity acquired by a body, by a freely falling body, if height of fall is equal to 180 meters. It's quite simple. Okay, 60 meter per second. Let us try to solve one more problem. A girl throws n balls per second at regular time intervals. When the first ball reaches the maximum height, she throws the second one vertically up. So when the first ball has reached the maximum height, she is throwing second ball vertically up. It means that the time gap between first ball and second ball is how much? Equal to time of ascent, u by g. Because first ball is at the maximum height and the second ball is about to start from the initial position, right? So obviously whatever regular time intervals he is talking about, that time interval is equal to how much? What time of ascent. Okay, so what we have to find out the maximum height reached by each ball. So let us imagine this picture. Okay, so this this way of playing with the balls is called as juggling. So here the first ball has gone to the maximum height and the second ball has been released from the hand. Okay, here I have taken only 3 balls. In fact, you can take any number of balls. N can be 3, 5, 10, anything. Okay, so what we have understood from the question, time interval between 2 balls is equal to time of ascent. Whatever description he has given in the question, from that this is obvious. Time interval between 2 balls is equal to time of ascent. And time interval between 2 balls is how much? All these n balls are projected after regular intervals of time. So time gap between 2 consecutive balls will be 1 by n. And that 1 by n is equal to how much? Time of ascent, which is equal to u by g. We know about this one. Time of ascent or time of descent, both are equal to u by g. So from this equation, we can find out what u is. U is equal to how much? G by n. If we know velocity with which a body is projected in the upward direction, can't we find maximum height acquired by the body? Yes. That maximum height is equal to u square by 2g. And here u is how much? G by n. Replace with g by n, what you will get? G square by 2n square g. G gets cancelled, and finally maximum height acquired by the ball is equal to g by 2n square. Okay, so with this I will close the session, students. Try to solve a few more problems based on this kind of details. Okay, so thank you, students.